Okay, so we've done drawing the scatter diagram, we've done investigating how to choose which scatter diagrams to choose with your scatter matrix, we've fitted a trend line, we've looked at investigating a point. The last thing I want to talk about is about looking at categorical changes and seeing if there's the same relationship or a different relationship there. And I'm going to try and do that with two different sets of data. So the first set of data is the sports science data. This is from NZQA's website. I'm going to use sum of skin folds and I'm going to use percentage body fat. Insight can't cope with the percent sign, so it's got an X there. And there you go, there's my trend line. And I'm going to fit my trend line and I'm going to make that a linear one. And that's pretty good. I'm a little bit concerned at the top here that I've got from 100 and probably 130 no trend points above the line, but I've got a good cluster of points above and below the line all the way along. I would say that no point is further away from the line than any other point. It does kind of fan out at the start of the line, but it's a pretty good trend. And if I get the summary, I've got a reasonably good equation there, which begins to make sense that, the percentage of body fat isn't zero when the sum of skin folds is zero, and that does kind of make sense. So I'm relatively happy with that. But now I want to look at, is this relationship the same with a couple between the genders? So I'm going to drag gender, badly labelled as sex there, I don't think that's appropriate really, into this, and I get two new graphs. Now I get one graph for the females and one graph for the males, and if I use this slider, I can look at each graph separately, but actually I want the comparison of them on the screen together. Now when I click the Get Summary button, it gives me both equations. Now, it shouldn't really surprise anyone that when you categorize the data, it may or may not make the correlation number higher, but I'm more concerned about the equations. If I look at those, my two equation numbers are roughly the same. If I was rounding those to 2dp, it'd be 0.16 in both equations. So my gradient is the same. So it says that the sum of skin fold, or the percentage of body fat, goes up at the same rate based on the sum of skin folds. But the other thing that's interesting is the y-intercept. Now my y-intercept for females is 4.2 and the y-intercept for males is 0.85. And that kind of suggests that males and women, or men and women, store fat differently in their bodies. And therefore there is a difference. So I could, oops, wrong one. I can safely say that there is a relationship there, that they both follow the same trend, however, they do things slightly differently. If I go to the subspecies data though, and forgive me while I have to navigate my directory structure to get there. This is data about Hector's dolphins, and I'm going to do that relationship. I'm looking at my curve. I can see there's a relationship. I've got an even scatter above and below the line. I've got a few points that I'm a little bit concerned about. There seems to be a moderate-ish correlation there. It's moderately strong, I'd say. There's a tight band around which to predict. But if I now look at the island that these animals are from, I get a completely different relationship. The trend line is increasing at a different rate, and the y-intercept is different for both animals. So not only are we saying that Island 1, which is the North Island, they are bigger because they obviously have more access to food, but the rate of growth is different, which implies that they may not be the same species. Okay? So you're looking for things that are the same in these two trends, and you're looking for things that are different. See you next time.